Backpropagation, the algorithm that powers modern deep learning. But why does it feel so backward? Let's start with the basics. A neural network is a mathematical function that transforms inputs into outputs. It consists of layers of neurons. Each neuron is connected to neurons in the next layer. The input layer receives data. Hidden layers process it. The output layer produces a prediction. Let's watch data flow through the network. This is called the forward pass. Now let's see what happens when the network makes a prediction. We'll compare it to the actual target value, but the actual target values are different. The first output should be 0.15, not 0.82. The difference between prediction and target is the error. Let's visualize this error. The loss function quantifies this total error. For this example, we use squared error loss. Now here's the key question. Which weights cause this error? We need to compute the gradient of the loss with respect to every weight. There are dozens of weights in even this small network. Computing each gradient separately would be extremely inefficient. Backpropagation solves this elegantly. It computes all gradients in one backward pass through the network. The mathematical secret is the chain rule. Let's see how it works with a simple example. Imagine we want to know how a weight in the first layer affects the loss. The weight affects the next layer, which affects the next layer, and so on, until finally affecting the loss. The chain rule says, to find the total effect, we multiply the effect at each step. This is a composition of derivatives, and here's the key insight. We can compute these derivatives backwards, reusing results from later layers. Let's watch backpropagation in action. First, we compute the gradient at the output layer. Now we propagate these gradients backward through the network. At each layer, we compute how much each neuron contributed to the error. Once we have all the gradients, we can update every weight to reduce the error. This is gradient descent. So why does backpropagation work backwards? Let me show you with a visual comparison. Imagine computing gradients the naive way, going forward. For each weight, we'd have to trace its effect all the way to the output. But with backpropagation going backwards, we compute each gradient once and reuse the results. This is much more efficient. The key insight, the loss only exists at the output. By starting there and working backwards, we compute each gradient exactly once. Let's bring everything together. Backpropagation is the algorithm that makes deep learning possible. Step 1. Forward pass. Data flows through the network to create a prediction. Step 2. Compute loss. Compare the prediction to the actual target. Step 3. Backward pass. Using the chain rule, propagate gradients from output back to input. Step 4. Update weights. Use the gradients to adjust every weight in the direction that reduces the error. It feels backward because we start where the evidence is, at the output. But this backward direction is precisely what makes the algorithm efficient. Backpropagation is the engine of modern deep learning. Thanks for watching. This is Gradient Canvas, where we make AI beautiful and understandable. If you enjoyed this video and who want to understand AI concepts, please like, subscribe, and share it with others. Join us to explore more AI concepts from neural networks to transformers. See you in the next video.